Hello everyone. In this lecture we will discuss subset construction method. This method is used to convert NFA into DFA. Now suppose we have regular expression 0 plus 1 whole star 0 1. For this regular expression we can plot NFA. So NFA at a start state we can mark self loop for 0 comma 1 for this 0 plus 1 whole star. It is followed by 0 1, so we can mark a state for input symbol 0, then we can mark next state for input symbol 1. Now we know that this is NFA because at Q naught for symbol 0 there are two outgoing transitions. Now we'll take input string that is suppose 0 0 1 0 1. Now we'll try to see the processing of this input string for this non-deterministic finite automata. Now here we will start from Q naught. At Q naught, after reading symbol 0, we can move to state Q1. At Q1, we'll look for transition, we will look transition for input symbol 0. But at Q1 for 0, there is no transition. So here we'll stuck. Now next possibility, at Q naught we are reading input symbol 0 and going back to state Q naught. Now at Q naught, next after reading 0 we are moving to state Q1. Now the next input symbol is 1. So at Q1 for input symbol 1 we'll move to state Q2. Now next input symbol is 0 and at Q naught for 0 there is no transition. So again we'll stuck at this point. Now see the next possibility. At Q naught, after reading input symbol 0, we are coming to Q naught again. Then again we are reading 0. So after reading 0, we can come to Q naught. Then 1. So after reading 1, again we are coming to Q naught. And then 0. Then for 0, we are moving from state Q naught to Q1. And then input symbol is 1. So for 1, from Q1, we are moving to state Q2. So this is end of the string and we are reaching to final state. So we can say this is final state or string accepted. Now see the next case. After reading 0 0 1, we will be at state Q naught. Now next input symbol is 0 and again we can use this self loop only and we can move to again state Q naught. Now next input symbol is 1. Again we can use this self loop and we can go to state Q naught. So entire string is processed, but we are at a state Q naught and Q naught is non-final state. So this is the another possibility of processing this input string. So we can plot the transition table for this given NFA. So we can easily plot the transition table. At state Q naught for input symbol 0, next states are Q naught and Q1. So here we can write Q naught and Q1. Now at state Q naught for input symbol 1, next state is Q naught. So here we can write Q naught. At Q1 for input symbol 0, there is no transition. At Q1 for input symbol 1, next state is Q2. Now at Q2 for 0 and 1 there is no transition. So in that way we can plot the table. This table is showing the transition function and mapping is Q into sigma to 2 raised to the power Q. This we have already discussed in our previous lecture. Now suppose we have a non-deterministic finite automata defined over 5 tuples Qn, sigma, delta n, Q naught and Fn. Its equivalent DFA is defined over these 5 tuples Qd, sigma, delta d, Q naught in curly parenthesis and Fd. Equivalent mean this NFA will produce one language. Similarly, this DFA will produce one language, and language produced by both the finite automata should be equal. So we will use here subset construction method to convert this NFA into DFA, defined like this, formally defined like this. Now see the idea. Now suppose we have an NFA like Q naught, and suppose alphabet is 0 comma 1. Now for input symbol 0, next state is suppose Q1, and here same for input symbol 0, next state is suppose Q2. So this is NFA, so we can say for particular state, for in particular input symbol, there can be multiple outgoing transitions. Now this is NFA. We need to obtain its equivalent DFA. In DFA we know, now suppose this is the start state. Now this, from this state, for input symbol 0, there should be only one state. Now here we can say that here we have two states. So for input symbol 0, we can say we are moving to states Q0, Q, comma Q1. Now in DFA, only one state is possible, right? Now choices are deterministic here. So here we'll write this pair, and this pair should be considered as single state. This pair should be considered as single state. So we can say that in a particular NFA, suppose this NFA is having n number of states, so we can say then 2 raised to the power n number of such pairs are possible. So we can say in DFA there will be 2 raised to the power n states, because 2 raised to the power n such pairs are possible in DFA. Now suppose in NFA number of states in Qn are n. So in DFA we can say that maximum number of states will be 2 raised to the power n. Right. Now see, take one example. Suppose Qn, the states in Qn are 3 states are there, Q0, Q1 and Q2. Now power set of Qn will be all possible states, all possible subsets of Q0, Q1 and Q2. So all possible subsets of Q1 and Q2, Q0, Q1, Q2 will be 5, Q0, Q1, Q2, pairs like Q0, Q1, Q0, Q2, Q1, Q2 and Q0, Q1, Q2. Now often not all states are accessible from start state of QD. Such states can be thrown away. So effectively, number of states in deterministic finite automata may be much smaller than 2 raised to the power n. So we can write for all S subset of Qn and for all A in sigma, delta D of S comma A is equal to union of delta N of P comma A, where P is an element of capital S. Now we will solve one example to better understand subset construction method. So suppose we have this NFA, Q0, Q1 and Q2 are the states in NFA. It is defined over alphabet 0, 1. It is defined over alphabet 0, 1. Now this is the transition table for this NFA, and this is the formula that will apply to convert the given NFA into DFA. Now we'll do the steps. First of all, we know that in NFA start state is Q0, right? So in DFA start state will be the Q0 in form of set. Now we'll apply this and we'll obtain the transitions. Now here we'll apply delta D, mean we'll obtain move in DFA for start state. Now suppose Q0 and we are giving name to this state is capital A. So we will start from capital A and initially the input symbol is 0. So this will be equal to union of, for all elements in capital A, will obtain move in NFA for P and input symbol 0. Right. So in A we have Q naught. A is a name of set and element in set. So element in set is actually Q naught. So we will obtain Q naught comma 0. Q naught comma 0. So it will be equal to, at Q naught for input symbol 0, next states are Q naught and Q1. Q naught and Q1. So we can give name to this set as, suppose this is capital B. Parallelly, we'll draw its transition table. So its transition table can be drawn like this. So here we are drawing transition table for its equivalent DFA. So in DFA, start state will be capital A. Capital A is Q naught in curly parenthesis. Now here we'll mark the transitions. We'll write the next state for input symbol 0 and input symbol 1. Now at A state for input symbol 0, next state is B. So here we will write B. Now we'll apply, then we'll do the next step. Again using the same for delta D of capital A comma 1 for all symbol in A. So that will be equal to union of, for element P in A, delta N of P comma 1. Now at A mean, element in A mean Q naught. At Q naught for input symbol 1, next state is Q naught. So here we will write Q naught. And name corresponding to Q naught is A only. So here we can write A. Now new appearing state is capital B. So now we'll look the transitions for B. Mean here we will write B. So what are our objective for state B? For input symbol 0, the next state. So we'll remove in DFA from state capital B and input symbol 0. A union of P belong to B, move in NFA and P comma 0. So B is actually equal to Q naught and Q1. So union of these elements. So we can write it like this. Delta N of Q naught comma 0 union delta N of Q1 comma 0. So here we will obtain delta N, in delta N Q naught comma 0. So we will obtain Q naught comma Q1 union at Q1 for input symbol 0, next state is 5. So we'll obtain here Q naught comma Q1. Q naught comma Q1. This is equal to B. So at B for input symbol 0, next state is B only. Now at B for input symbol 1, again we'll apply this. So that is Q delta D input symbol B, state B and input symbol 1. So this will be union of P belong to capital B, delta N, P comma 1. So this will be equal to, in B elements are, P will be Q naught and Q1 and union of it. So we'll write delta N, Q naught comma 1, union delta N, Q1 comma 1. So at Q naught, for input symbol 1, next state is Q naught union at Q1 for input symbol 1, next state is Q2. So we will obtain Q naught comma Q2. So we can give name to this state as C. So here we will move to state C. Now new state is C here. So again we will apply this for state C input symbol 0. So delta D state C input symbol 0. U P belongs to C, delta N P comma 0. So this will be equal to delta N. In C elements are Q naught and Q2. So we will write Q naught comma 0 union delta N Q2 comma 0. So at q naught for input symbol 0, next states are q naught, comma q1. Union at q2 for input symbol 0, that is phi, empty set. So here we will obtain q naught, comma q1. So at state C for input symbol 0, next state is B. Now delta D, state C, input symbol 1, union P belongs to C, delta N, P comma 1. Now that will be equal to C mean q naught and q2, input symbol 1. So here we will write delta N q naught comma 1 union delta N q2 comma 1. So q naught comma 1 will lead us to q naught union q2 comma 1. So at q2 for input symbol 1 phi. So here we will write phi and we'll get q naught. So at C for input symbol 1, next state is A again. So in that way we can plot its transition table. Now we can draw the transition diagram also for deterministic finite automata. So here states are A, B and C. Here start state is A only, the state in which q naught lies, so it will be start state, and here final state is q2. Now we'll see in which state q2 is lying. q2 is lying in this set q naught q2, so final state will be C. So we can mark this as a start state and state C as final state. Now at A for input symbol 0, next state is B. For input symbol 1, next state is 1. So here we'll mark self loop. At B for input symbol 0, next state is B only. So we'll mark here self loop. At B for 1, next state is C. So here we'll mark 1, transition for 1. At C for 0, next state is B. At C for 1, next state is A. So this is deterministic finite automata for given NFA. Thank you.